Hey everyone. In this video, we're going to be talking about reactions of alkenes and alkynes. Now, all of these reactions are what we call an addition reaction. So this is the general type of reaction. Now, when an addition reaction occurs, one bond of a double or triple bond is broken and two new single bonds are formed. So if this is our double bond, one of these bonds is going to break, and we're going to form two new bonds. And so some molecule here, XY, is going to attach where the double bond used to be, and X is going to go to one side and Y is going to go to the other. And so if we're looking at these bonds here, this bond breaks and this bond breaks, and they reform here and here. And so we're not losing any electrons. Every time a bond breaks, it reforms to something else. And so we're losing one bond from the double bond, and we're losing the bond between X and Y, and we're forming two new single bonds so that X and Y are attached to the carbons where the double bond was. So there's two types of addition reactions that we're going to be looking at in this class. The first type is known as a hydrogenation. And as the name implies, we are adding hydrogen. So hydrogenation, we're adding hydrogens. Hydrogen gas is H2. And so we're adding two hydrogen atoms where the double bond used to be. And we use a metal catalyst. The second reaction is known as a hydration reaction. And so just like hydrating means to drink water, well, hydration reactions are when an alkene absorbs water, specifically as H and OH, where the double bond used to be. And we usually use a strong acid catalyst like sulfuric acid. So once again, the two types of reactions are hydrogenation and hydration. In hydrogenation, you have an alkene plus hydrogen. Your catalyst is either platinum, nickel, or palladium metal, and your product is an alkane. In hydration, we have an alkene reacting with water. The catalyst is a strong acid, and the product is an alcohol. And we haven't learned this yet. This is the next chapter, but alcohols are anything with an OH group attached. So because we have this OH group attached to carbon, it's known as an alcohol. So let's take a look at hydrogenation reactions in a little more detail. So hydrogenation, as the name implies, is the addition of hydrogen in the form of H2. We're adding it to either a double or triple bond. The catalysts can be any heavy metal, but it's usually platinum, nickel, or palladium are the most common, and these speed up the reaction. The product of a hydrogenation is always an alkane. So an alkene plus hydrogen makes an alkane. We're breaking one of the bonds from the CC double bond. We're breaking the bond between the two hydrogens, and we are reforming bonds between carbon and hydrogen. So we're adding two hydrogens to the two carbons where the double bond used to be. Let's do a practice. Write an equation for the hydrogenation of ethene using a palladium catalyst. So what does ethene look like? Eth means two carbons. Ene tells us there's a double bond. So two carbons, double bonded. Every carbon needs 4 bonds total. So that means that there must be 2 hydrogens attached to each carbon. This is ethene. It's a hydrogenation reaction. So that means it's reacting with hydrogen gas. And we usually just write the catalyst above or below the arrow. So palladium is just PD. These metals act as like a surface for the alkene and the hydrogen to bind to, and it just helps the reaction occur more easily. These are both gases, and so normally they're just flying around, not bumping into each other. But if you have a metal surface, they'll bump into the metal surface and stick long enough for the other one to come in and collide. So having these metals allows it to react better. So there's our catalyst. So what's the product going to be? Well, we know that one of these bonds is going to break, and we know that this bond is going to break. And so our product will still have the original hydrogens, but now we're forming two new bonds to the new hydrogens. So these two hydrogens here are now attached there and there. And the bonds that we broke reformed here and here. And so the ethene is now ethane. This was an alkene because it had a double bond. This is an alkane because it's all single bonds. So there we have it. Two hydrogens added. Not too bad. Let's take a look at the hydrogenation of alkynes. So remember, an alkyne is a triple bond. And so alkynes react with two equivalents of hydrogen gas, meaning you're adding a total of 4 hydrogen atoms across the carbon-carbon triple bond. The product is still an alkane. So here, we're going to be adding 4 total hydrogens where the triple bond used to be. And so these 4 hydrogens are now here, 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 and here. And we made 4 new bonds. And those came from the bonds between 2 hydrogens here and from the triple bond. So the same reaction that we did with an alkene, but we're just adding twice the amount of hydrogens. All right, let's do some practice. Predict the products of each of the following reactions. So anywhere there is a double bond, we're going to be adding the hydrogens to the carbons where the double bond is. So keep the same general structure, but where those carbons were, instead of a double bond, now we've got 2 hydrogens attached. Same thing here. We've got a carbon-carbon double bond between those 2 positions. So we keep the same general structure, but at those 2 positions here, we're adding hydrogens. And the last one is an alkyne. And so at those 2 positions, we're going to be adding 2 hydrogens each, because we're adding a total of, whoops, that's a typo. That was supposed to be a 2 there. Because we're adding 2 equivalents of hydrogen for an alkyne, we should be adding 4 total hydrogens. Excuse the typo. And so there we have it. Oh, no typo on this one. But yeah, so alkenes add 2 hydrogens where the double bond used to be. Alkynes add 4 hydrogens where the triple bond was. Let's take a look at hydration reactions. So hydration is the addition of water across the CC double bond. Now, water is HOH. We're going to be breaking the bond here. And so one carbon gets the hydrogen, the other carbon gets the OH. So we're adding water, but really we're adding H and OH. And so here's the double bond. We're breaking one of those bonds, and then we're breaking this bond here in the water. And we're forming that bond there and that bond there. And so one carbon gets hydrogen and the other carbon gets OH. And anytime you have an OH connected to carbon, we call that an alcohol. So the product of a hydration is an alcohol, HOH. Let's do a practice. Write an equation for the hydration of ethene using sulfuric acid as the catalyst. So ethene, once again, is a carbon-carbon double bond, 2 carbons, 4 hydrogens. Looks like that. And we're reacting it with water, which looks like this. And our catalyst is H2SO4. I'll just write that over the arrow. So the bonds that we're breaking are that one there and that one there. And so we're going to be adding H to one side and OH to the other. Still have 2 hydrogens attached to each carbon. That didn't change. And we're now adding our H and our OH. So there we have it, the product of our hydration reaction. We added hydrogen and OH where the double bond used to be. Now, this can be a little more complicated. In this example, it was easy because our starting alkene was symmetrical, meaning if you took this molecule and split it down the middle, it's the same on the left half as it is the right half, so it's symmetrical. And so for a symmetrical alkene, it doesn't matter which side gets the H and which side gets the OH. It doesn't really matter. But for an asymmetrical, meaning not symmetrical alkene, it does matter which side gets the H and which side gets the OH. And so this is determined by what's called Markovnikov's rule. This is the name of the Russian chemist who discovered this. Essentially, the hydrogen attaches to the alkene carbon that already has more hydrogens. The OH attaches to the alkene carbon with fewer hydrogens. And so one of the easy ways to remember it is hydrogen wants to be with his friends. So if we're looking at this starting material here, it's asymmetrical, right? If I draw a dashed line down the middle, the left side is different than the right side because of this CH3 group. Now, the carbon on the left here only has 1 hydrogen attached. The carbon on the right has 2 hydrogens attached. So when we add the water, the hydrogen wants to go to the carbon that already has more hydrogens. So he goes with his friends. The OH goes to the carbon that had fewer hydrogens. So this is the major product of the hydration of this asymmetrical alkene. Let's do some practice. Predict the product for each of the following hydration reactions. Now, on this one, it's a skeleton, so they're not showing you the hydrogens, but if we were to fill them in, we've got a hydrogen here and a hydrogen there. So looking at each carbon of that double bond, they have the same number of hydrogens. They both have just one. So it's symmetrical. It doesn't matter which side gets H, which side gets OH. So if these were our carbons, one gets the extra hydrogen and one gets the OH. So for the one on the bottom here, this one's not symmetrical. This carbon here has a hydrogen attached, whereas this is a CH3 group up there. That's a methyl. And so when we add H and OH, the hydrogen wants to go to the side that has more hydrogens already. And so our product will end up with 2 hydrogens at this position, and the OH will go to the side that had fewer hydrogens. So there we have it. All right. To recap this video, addition reactions are when you add a compound to a double or triple bond. The 2 types of addition reactions were hydrogenation or hydration. In hydrogenation, you're adding hydrogen and you use a metal catalyst. The alkene becomes an alkane. If you hydrogenate an alkyne, you add 2 equivalents of hydrogen for a total of 4 hydrogen atoms, but you still end up with an alkane. Hydration is the addition of water using an acid catalyst. You're adding H and OH. And for an asymmetrical alkene, the hydrogen goes to the carbon with more hydrogens. The OH goes to the carbon with fewer hydrogens. Thanks for watching, and I will see you in the last video.